interesting facts of the universe. And I know, Steve, that on our Waves of Tech, our tech podcast, part of the Netcast Studio family of podcasts here, we actually talked about Juno spacecraft and its launch by NASA going out to Jupiter. So it feels like we kind of have a space theme going on here. Of course, being my interest in space and the space shuttle and everything like that, this was another great topic that you came up with, and something, of course, that I always find fascinating, something I'm always going to learn something from, no matter how much you look and how much you research and study it. Always something fascinating with science and the universe and outer space going on.
I think what's unique and what's really kind of interested me of late is because technology has gone so far now, the things that we're learning about the universe. And will we know where it really came from? Not really, I don't think. But it's just so fascinating and so interesting. And some of the stuff is so mind-boggling that I don't even know how you comprehend some of it. It's so massive, so vast, so interesting. So what I thought we'd do, Dave, is you and I will just kind of go back and forth on an interesting fact about the universe, and we'll chit-chat about it. How's that?
Sounds good to me, man. Let's do this. What do you got first?
Well, I'm going first?
Oh, yes.
Okay.
Curveball.
So the first one that I'll come up with is the universe is 13.7 billion years old. And that's a pretty incredible number. And when we think of history, when we think of lifetime, which is very short in nature, when we talk about the initialization and the beginnings of the universe being almost 14 billion years old, it's just fascinating. And how do we come up with these numbers? You know, the scientific community has developed various kinds of testing experiments and ways of investigating the universe to discover its birth. I think that's a quite amazing number.
It really is. And, to think of the measurements and the calculations that have gone into that and the amount of years it has taken to come up and formulate that number, it's pretty impressive. One of the things that I thought was pretty cool, Steve, is that a huge chunk of what is made up of things that we can't even see in the universe. For example, different wavelengths in the electromagnetic spectrum, such as those as radio waves, infrared, X-rays, and visible light, have allowed us to peer into the cosmos and see huge portions of it. Unfortunately, an even larger portion cannot be seen by any of these frequencies. So there is a lot more different wavelengths and things out there that exist, but we can't see them through either, a spectrum, telescope, whatever it is. And yet, certain phenomena such as gravitational lensing, temperature distribution, velocities of some of the orbits, and all these others are evidence of a missing mass of existence. And it's so weird that there's so much out there, and with even like we talked about previously, with the technology being as sound and as strong and as fresh as it is, there's just a whole lot that we just still can't see. And that just proves to the vastness of universe and how much more we still have to grasp and still have to learn about this. And all that stuff can filter down into education, into science and engineering and everything else. But I thought that was interesting. There's a huge chunk of what's made up of things that we just cannot see.
Yeah, that's interesting and those are the things that we know about that have been discoverable, but what remaining things are out there that we yet don't know? It's very interesting. The Earth spins in rotational 1,000 miles per hour, but travels through space at 67,000 miles per hour. No wonder I'm always dizzy.
I know. For some reason, my equilibrium is always just a little bit off.
It's just a tad, huh? That's hauling.
Yeah, it is.
When you those kind of when you go to like a fair or a circus ground, and it has like, I don't know, tentacles, and you have something you sit in, so the inside spins, then the outside things spin. That's kind of what this is. The rotational spin of the Earth is 1,000 miles an hour, but as we're traveling around the universe, it's at 67,000 miles an hour. Incredible speed.
That is really crazy. One interesting fact as well, Steve, is that the Earth is not flat. Of course, there is a big, huge conversation or discussion or debate, if you want to call it back, with Galileo and the Catholic Church and all that stuff in way back times. But there was a discussion of the Earth being flat or not flat. But the universe actually is flat. and this is weird to think about, because everything we've heard, Earth is round, all the planets round, stars, all these things. But based on Einstein's theory of general relativity, there are only 3 possible shapes that the universe can actually take. And it's open, closed, or flat. And once again, based on the measurements that they use with a mapping system or a microwave program, they have released a monumental confirmation that the universe is flat. And combing this, the geometry and the idea of an invisible entity known as what they call dark energy coincides with the widely accepted ultimate fate of the universe, which is stated early as what is called as a big freeze. So we like to think of everything. It's got to be shapes, what's closed, is the universe closed, is it this, is that, but it's actually flat. And I assume since Earth was round and everything else was round or open, it had to be as well. But no, universe is flat.
It's interesting. I've been watching some documentaries on that perhaps space isn't really 2-dimensional nor 3-dimensional, but it's 4-dimensional. And it's a very interesting topic. So if you ever get a chance to look into that a little more deeper, I would. So Dave, there are billions of galaxies in the universe. We are in one galaxy, the Milky Way, but there are billions of galaxies. And if that sounds insane, in each of those billions of galaxies, there are billions of stars. So that means, as far as we know right now, that there are 10 billion trillion stars in the universe. Wow. How do you put your head around that?
Yeah, it's crazy. I mean, you look up into the sky at night and you see a handful of stars, based on how clear the day is, what's in the air, whatever. But you can look up in the sky and see what you think to be thousands of stars and be like, wow, there's so much going on up there. And that's just a pinch. That's just a little drop in the bucket of what is out there in regards to not only our Milky Way galaxy in which we belong to, but the whole scope of the universe. And just to think that you had said 10 billion trillion stars in the universe, that's pretty dang impressive. That's hard to wrap around.
It is, and I'm actually surprised you can see any stars where you live.
Oh man, our air quality has been getting so much better. You can sit out there and see all the stars in the world, man. It's getting better out there. But crazy enough, the sun is actually a star, and it takes about 8 minutes for light from the sun to reach Earth. So think about that, 8 minutes. That means if the sun was to go black, we wouldn't know it for almost 10 minutes, And I don't think we mentioned this before, but the speed of light travels at approximately 186,000 miles per second. So that's pretty impressive. That also gives you the scale of how far away the sun actually sits from us. But also, if you could travel that fast at the speed of light, which is 186 miles per second, it would still take you 100,000 years to cross the Milky Way galaxy alone. So that's pretty crazy. Just a stat right there. A few little things going into the planets, Steve, and amazingly, Saturn is less dense than water. You can imagine the scale of Saturn and everything that goes on. It says if you dropped it into a pool of water, it would float like an ice cube.
Isn't that something?
Isn't that crazy? And inversely, Jupiter is one of the heavier planets in the solar system, but it's actually been coined the solar system's vacuum cleaner. It actually pulls in meteors and comets, and scientists estimate that if it was not for the vacuum type system that Jupiter has, the number of these objects hitting Earth would be about 10,000 times greater. So thanks to our buddy up there, Jupiter, keeping the old Mother Earth safe here by taking in all the meteors, comets. I'm wondering if also, speaking of NASA, with their Juno spacecraft going up to Jupiter, I wonder how it's going to react to that vacuum sort of pull. I didn't know that about Jupiter until we had just talked about this. So obviously, if it can suck in meteors and comets, can it also do that with, the different satellites that are out there in space as well? So interesting fact maybe we can come up with, but just some cool little things about Saturn and Jupiter individually.
Absolutely. You mentioned the sun. What a unique, interesting item that is. And, some of the coolest stars are only about 500 degrees, and some of the hottest ones reach up around 90,000 degrees.
Wow.
Now, our sun itself is kind of in its midlife crisis. It's about halfway done through extinction. Don't let that worry you, though. It still has about another 5 billion years of life left in it.
Hopefully I'm not around by then.
I'm too old as it is now. I don't want to live 5 billion years.
Oh man, think of the things you could see, though.
I know, it'd be cool. I wonder if my iPod will still work.
use it to keep those upgrades going. You know? Maybe.
Just
Apple,
maybe,
I know, will be around for another 5 billion years. I'll tell you that much.
Yeah.
Seems like the only company going strong.
That's true. Hey, Dave, I'll finish this up by just saying also that, is there a difference between a star and a sun? In relative speaking, no. Very technically speaking, there is, in that normally a sun is classified by the term sun if it has a planet within its rotation. There it is.
Very interesting. Yeah. I mean, that's just good little factoid right there as far as just a definitional, difference right there. Going on, Steve, I thought this was pretty interesting. This is a fact that the moon is actually drifting away from Earth. And every year the moon moves about 3.8 centimeters, which isn't very far, but still that's some movement. Moves about 3.8 centimeters further away from the Earth. This is caused actually by tidal effects. Tidal waves and tidal effects and everything like that. Consequently, the Earth is slowing in rotation by about 0.002 seconds per day per century. So that's not a whole lot of time, but still, if you think of them drifting away, slowing down, there's some consequences there. Of course, scientists do not know how the moon was created. That's a consensus there, but the generally accepted theory suggests that a large Mars-sized object hit the Earth, causing the moon to splinter off of Mars. And so that's kind of interesting. But hey, moon's drifting a little bit away from Earth. That's something I didn't know. So another interesting fact about what's going on out there in the universe.
So when Big Bang happened, was it hot? Actually, they're estimating that when the Big Bang happened, the temperature was about 1 billion Kelvin. Now, when you look at today's universal temperature, it's only about 2 Kelvin. So you can see the vast differential and the explosive heat nature that happened during Big Bang.
It's pretty hot.
I don't know how hot a Kelvin is, but it's hot.
It's hot. Yes, exactly.
Because we are not scientists.
No. We're just the administrators of information. That's all we are, distributors. Getting some other interesting facts, Steve. Maybe I talked about debris a little bit earlier, in the satellites and everything that are out there, pieces of equipment that have been, abandoned out there in space. So it's known to be about approximately 10,000 pieces of equipment that are revolving around the Earth currently. About 3,000 of these pieces are satellites, and the rest are bits of debris, pieces that have fallen off, things that have been, decommissioned and just let to float out there. And so you can imagine with all these pieces, Steve, floating around orbit, what the space shuttle has to do to kind of avoid all those things. What goes into the planning process. I guess you can steer the space shuttle through space. I would think so, to avoid debris and things like that. But over 10,000 pieces. I never actually knew the real number, but I knew there was a lot of it out there, with as many satellites from all different countries that are sending things up there. And now that businesses and everything else are doing it as well. That's a lot to think that's up there in space. But when you think about the vast size of the universe, probably not. You can probably avoid it pretty easily. You know what I'm saying?
Oh, absolutely.
Yeah.
These are great facts.
Yeah, one other thing, comets. A comet's tail always points away from the sun. Something I didn't know.
That's interesting. I wonder why.
Yeah, well, I'm not sure. Let's see. Well, until the mid-16th century, comets were believed to be not astronomical phenomenon, but they're actually believed to be burning vapors that had arisen from distant swamps and propelled across the sky from fire and light. So that's a little historical perspective on where they thought the origins of comets came from, but I'm not exactly sure why the tail always points away from the sun. Running away from mom? Running away from dad? I don't know.
Good point. We were talking about the sun, and the sun has such a gravitational force that if a 150-pound man was standing on the sun, besides being burned up, the person would weigh over 2 tons.
Whew.
Amazing. It's crazy. You know how much the moon weighs?
I was just going to mention that because we had talked about the moon moving a little bit farther away from the Earth. It weighs 81 billion tons.
How do
Try
they
and
know
bench
that?
press that, Steve.
What do? They have a floating scale in space?
It's going to be at the quite the large scale there. Yeah, I don't know. It's obviously some density. Obviously, we've been able to go on the moon so we can take samples and maybe drill down and dig. I'm not sure exactly, but some sort of density calculation that these crazy scientists and mathematicians have come up with. But yeah, 81 billion tons. That's a lot.
What is it? It's like a pulsar, which is a small star made of neutrons, and they're so densely packed that if it was the size of a silver dollar and it landed on the Earth, it would weigh approximately 100 million tons because of its density.
Wow.
I mean, some of these numbers, they're mind-boggling.
Yeah, you just have to say, that's cool. You know?
That's cool. It is what it is. So, you got any last-minute ones, Dave? Or?
Yeah, some things that always have been of interest to some people, and those would be black holes. You know, and black holes is basically the cold remnant of a former star. So when the star explodes, all the cold remnant is considered a black hole, and it is so dense that no matter, not even light, is able to escape from its gravitational pull. So everything in that black hole is just stuck in there. And black holes may exist through the universe, even within our own Milky Way galaxy. So they are part of our. That's basically how we understand it, is because we understand the Milky Way very, very in depth, like. And so, of course, I didn't know that they are so dense that not even light is able to escape. But yeah, it's black holes is always something that seems of interest. A lot of conversations always goes on. I remember in science class myself, in the physical sciences, going through and talking about this and learning about it as well. So pretty cool stuff.
Yeah, because it can get really insane when we're talking about quantum physics and string theory and all this stuff.
Yeah.
That even to the brightest people in the world, it blows their mind. You know, our universe is massive. Where did it come from? Who knows? You know, the Big Bang did happen, but where did all that information and fuel, and where did all that come from for the Big Bang to even happen? Mm-hmm. And this is only as far as we can reach that we know. Well, what is truly, really out there? How vast can it really be? It's an amazing, one of the very amazing things that are a part of our world, a part of what we live. And to me, it's just so fascinating.
Oh, it's absolutely fascinating. And one final point, Steve, is you had just mentioned that as the galaxy continues to expand and rupture and grow and all those things, there is no such thing as the universe's center. You know, of course, the Earth is not the center of the universe. It's not even the center of our own Milky Way galaxy, of course. But galaxy isn't even the center of the entire universe, you know? So, don't hold your breath, but the center has no center. It's always expanding, and there's really no way to ever find out what is the true center of the universe. And that's something interesting. I mean, we can pinpoint weights of the moon and how long the Earth has been around, but we can't pinpoint the exact center of the universe because it is so changing and so it's expanding all the time that there's just no possible way to even come up with it, because we don't know. We know there's billions of galaxies, but we don't know how far those stretch, you know? And so that's a cool little bit of unknown when it does come to the universe, something that we will never understand and we will never know as humans.
The universe is expanding, and what's it expanding into or through? Or what's on the other side where it can't expand? Questions of the universe. Mm-hmm. So Dave, I'm going to do a question of the week, since during our discussion you gave away the question.
Oh, did I?
So I have another one. That way you're off the hook. How's that?
Okay, I'll pay attention better next podcast.
It's fine, because that was good information that people do need to know. So this week's trivia question, since we talked about the Earth and the Sun and the speed of light, is how far away is our own Sun in miles? So if you would like to answer that, drop us a call on our listener line, or send us an email at feedback@netcaststudio.com. You can tweet it, Facebook it, you can even snail mail it if you want. It's fine with us. So Dave, any last thoughts about the universe?
Always something to learn. A bunch of interesting facts out there. I mean, we just touched just the very tip. You know, I mean, this is, you can make careers out of this. You can make educational programs out of it, and if it's something you're really interested in, I mean, you could study the planet Saturn for years upon years and still only understand a small fraction of it, because the universe is constantly adapting and changing and expanding. So all you science buffs out there, all you planetarians, follow it, man. Keep it going and keep us refreshed, because I know Steve and I, we always like to kind of peer into what the universe has to offer and what NASA and space, and it's all fascinating to us. So I was more than happy to share with you guys a little bit of what we know.
Oh, great, Dave. I appreciate you joining me again this week for another episode of Flash Past. And where we're going next week, nobody knows, even us. So, folks, thanks for joining in for another show. And get in contact with us. Give us some feedback. Chit-chat with us. We love it. So, Dave, we're going to jump